What is connection pooling? When too many app requests try to connect directly to PostgreSQL, the database gets overloaded. PgBouncer solves this by acting as a smart gatekeeper who reuses existing connections, reducing overhead. Key terminologies you must know. 1. Client connections. These are connections from your application, Nest.js, Node.js, Django, Rails, etc., to PgBouncer. 2. Server connections. These are the actual connections PgBouncer opens to PostgreSQL. 3. Connection pool. A pool is a bucket of reusable server connections. 4. Pool size. Defines how many server connections PgBouncer maintains. 5. Database plus user pair. PgBouncer creates separate pools per database per user combination. 6. Pooling modes. Session pooling, default. Provides full session-level stability, best for legacy apps. Transaction pooling, most recommended. Server connection is returned after each transaction, best for APIs and microservices. Statement pooling, most aggressive. Server connection used only for a single SQL statement, not compatible with transactions. 7. Authentication methods. MD5, Trust, HBA, Scram. 8. PgBouncer.ini. This is the core config file controlling pool size, listen ports, authentication, logging, pooling mode. 9. Auth file. Separate file storing user credentials. 10. Admin console. PgBouncer exposes a virtual DB. pSQL admin PgBouncer allows checking stats, viewing pools, killing connections, reloading config. How PgBouncer works internally. Let's understand how PgBouncer keeps your production database fast and stable. Step 1. App requests a connection. App hits Postgres/PgBouncer 6432. Step 2. PgBouncer receives the request. It checks pool availability, credentials, mode, session, transaction, and statement. Step 3. PgBouncer chooses a server connection. If a free connection exists, reuse it. If not, queue the request or reject if max client con reached. Step 4. Query runs on PostgreSQL. Step 5. Connection return to pool. Why PgBouncer is critical for production-grade apps. 1. Protects PostgreSQL from overload. Postgres cannot handle hundreds, thousands of connections efficiently. 2. Reduces CPU and memory usage. Creating destroying connections is expensive. 3. Makes scaling easy. Even if your app scales to 1,000 pods, your DB sees only around 20 connections. 4. More stable during traffic spikes. PgBouncer queues and reuses connections efficiently. 5. Improves latency. No waiting for connection initialization. 6. Enables zero downtime deployments. PgBouncer stays running even if the database restarts.